Today is a beautiful day for science. For the summary of 22nd to 28th of November 2021, I am going to also describe the filters that we see from SDO satellite, describing what each color represents from their imagery. The green sun, angstrom 94, is designed to study solar flares. It measures extremely hot temperatures around 6 million Kelvin, or 10.8 million degrees Fahrenheit. It shows the flaring regions of the corona. Primary ions are the 17 ionized iron. This is really good to see where these solar flares are occurring on the sun. This is angstrom 131, the blue sun, or light blue sun. It is designed to study the solar flares as well. It measures extremely hot temperatures around 10 million Kelvin, or 18 million degrees Fahrenheit, as well as cool plasma around 400,000 Kelvin, 720,000 degrees Fahrenheit. And it shows the flaring regions of the corona. Primary ions seen here are 20 and 7 times ionized iron. And this one shows you the hottest parts of plasma in the flares. So when you see that really bright area, that's the hottest plasma of that flare. The gold sun, angstrom 171, is especially good at showing coronal loops, the arcs extending off the sun where plasma moves along the magnetic field lines. The brightest spots seen here are the locations where the magnetic field lines near the surface is exceptionally strong. This also shows the quiet corona upper transition region at 1 million Kelvin, or 1.8 million degrees Fahrenheit. Primary ions seen here are 8 times ionized iron. This is the best filter for seeing the coronal loops as well. The bronze sun, angstrom 193, highlights the outer atmosphere of the sun, called the corona, as well as the hot flare plasma. Hot active regions, solar flares, and coronal mass ejections appear bright here. The dark areas are the coronal holes, where little radiation is emitted, but is the main source of solar wind particles. The filter shows the corona hot flare plasma at 1.25 million Kelvin, 2.25 million degrees Fahrenheit. Primary ions seen here are 11 times ionized iron. The pink sun, angstrom 211, highlights the active regions of the outer atmosphere of the sun, much like angstrom 193, the corona. Active regions, solar flares, and coronal mass ejections appear bright. The dark areas, called coronal holes, are the place where very little radiation is emitted, yet once again is the main source of solar wind particles. This shows the regions of the corona at 2 million degrees Kelvin, or 2 million Kelvin, 3.6 million degrees Fahrenheit. And primary ions seen here are 13 times ionized iron. And this is the best filter to see where the coronal holes are, to see where you're going to get that solar wind. The red sun, angstrom 304, is especially good at showing areas where the cooler, dense plumes of plasma, also known as filaments and prominences, are located above visible surfaces of the sun, or the surface of the sun. Many of these features either cannot be seen or appear as dark lines on the other filters. The bright areas show places where the plasma has a high density. It shows the upper chromosphere. The angstrom 304 shows the upper chromosphere and the lower transition region at 50,000 Kelvin, or 90,000 degrees Fahrenheit. The primary ion seen here is singly ionized helium. The dark blue sun, angstrom 335, highlights the active regions of the outer atmosphere of the sun, much like angstrom 193 and 211. Focusing on the corona, the active regions, solar flares, and corona mass ejections appear bright. The dark areas are the corona holes once again, which very little radiation is emitted, yet is the main source of solar wind particles. This shows active regions of the corona at 2.8 million Kelvin, or 5 million degrees Fahrenheit. Primary ions seen here are 15 times ionized iron. The pale sun, angstrom 1600, often shows web-like patterns of the bright areas. The highlights the bundles of magnetic field lines where they are concentrated. However, small areas with a lot of field lines appear black because the field lines themselves block the luminescence of the sun, usually near sunspots and active regions. The angstrom 1600 shows transition region and upper photosphere at 6,000 Kelvin or 11,000 degrees Fahrenheit, and 100,000 Kelvin and 180,000 degrees Fahrenheit. Primary ions seen here are thrice ionized carbon and continuum. The pale pink sun, angstrom 1700, often shows once again the web-like patterns in the bright areas that highlights places where the bundles of the magnetic field lines are concentrated at 6,000 Kelvin, 11,000 degrees Fahrenheit. However, small areas with a lot of field lines appear black, being that they block the luminescence, or the irradiance of the sun, usually near sunspots and active regions, and shows temperatures the minimum and shows temperature minimum and photosphere at 6,000 Kelvin, 11,000 degrees Fahrenheit. Primary ion seen here is continuum. And the good thing about 1600 and 1700 is you can see where the sunspots are more clearly to see if a region actually has developed. And the final is HMIBC, which is not actually a like the other filters. This one represents the polarity, which I can use to calculate where activity is going to occur based upon polarity strength and mix. Cheers and science on.